Yes, sir. Yes, sir. It is visible, sir.
Yeah. Yeah. So I'll be briefly discussing with the various landslide issues that have occurred in lateritic soils in Goa. And as you know, these lateritic soils are derived basically from the word later. And Buchanan was the first person who coined this term laterite. The Latin word later, which means a brick. And this was somewhere in 1807. So in Kerala, he has used this term laterite. And laterite as a soil or rock, they are known as residual soils. And these are formed because of the leaching action of basic silica and other components from the parent rock. So these are found in the tropical soils. So this is the tropic. If you see this, the red line shows the Tropic of Cancer and Tropic of Capricorn below belt. These are available in places like say Cambodia, Thailand, Kenya, Vietnam, Malawi, India, and so on. So these soils have typical characteristics. They are softer when they are wet and they are harder when they are dry. And they are formed as of leaching action of lime, silica, and organic matter under the action of high rainfall and high temperature. The various minerals which are found in this lateritic soil depend upon the nature of agencies responsible for this leaching action and the you can say quantum of you can say laterization that is taking place under these natural agencies. Basically, they are said to be in presence of high iron oxide content. So this is the pillar which is erected in Angadipuram, Kerala, in honor of Buchanan, who has coined the term laterite in 1807. And on the right hand side, you will find this beautiful ancient structure in Goa, which dates back to 6th century, the Pandava times. It was believed that Pandava visited this place and these caves were cut. And each cave doors are shown here now present. These doors are provided. You can see door is given to or allotted to each of the Pandava brothers. This is way Araulem in Goa. There is another, you can say, lateritic sculpture available in Goa. This Saint Mirabai, a 14 by 15 centimeters meter size cut picture is there. This is there in place called as Bigfoot in Lottering. So this picture shows this map of India, shows distribution of soils, different types of soils in India. And if you see the laterite, late Western Ghats, Eastern Ghats, Rajmal Hills, Vindhyas, Satpuras, and Malwa Plateau, and low-lying areas of Maharashtra, Karnataka, Andhra, Orissa, West Bengal, Kerala, Jharkhand, Assam, Meghalaya, and Goa. And they cover about 2.48 lakh square meters of area. So as far as Goa is concerned, this you can see left side, you can see the numbers where we find the lateritic patches here, this 1 to 10 here. So these are the, you can say, areas where you find very prominently. Now that's lateritic belts in Goa. This is another picture, shows the red spots shows in India. So you can see they are in some, then Goa, Kerala, Karnataka here, and also on the east coast and far northeast, place wherein we observe these lateritic soils. So there is in Goa also we find prominently the gneiss, which is not a transgramite gneiss. So this formation was believed to be about 1 billion years old. So this gneiss formation is observed. And also we observe this in place called as Kandgona, where the gneiss formation dates to 2.3 billion years. All these outcrops are seen in open. You can see the granites in Dudhsagar and Chandranath place, which are about 2. In Goa. So these are the varieties of rocks which we see in Goa. This process takes place. So this is the basic rock which you found in Goa is Greywack. So from which, because of this various natural agencies rainfall. As you know, Goa is having rainfall to the tune of about 3 meters annually. Are also quite high. It goes in summer, it goes up say 37, 38 degrees also. So because of this have high temperature and heavy rainfall, the of these minerals like silica and all, we find the laterite which is developed from the parent grave rock. And these are the various layers which we observe here as we see in the figure here. So on the top we find the duri crust which is known as indurated laterite, which contains iron oxide, alumina and silica. So below that we have what is called as vermiform laterite, underlain by semi-indurated laterite, which is a quaternary structure. This is also characterized by with a very soft clay layer known as saprolite. Okay, and this is below this there is Fe-rich mottled layer, then altered metagrave protolith, where this color changes from gray to reddish gray to present hematite and goethite, and below parent rock here. And this layer, the saprolite layer, is very soft layer which has been found, which is popularly known in local terms as lithomarge. Okay, so these are the characteristics of laterite which is observed in Goa. So here are a few of these lateritic profiles I'll be showing here. So you can see on the top we can see very hard massive laterite on the top, followed by gravelly laterite, layer of very soft clay there, and below that will be the parent rock. So this type of structure we find in many places, and when the road level is there, almost it comes in the area where this lithomarge level is there. So you can see the top portion in the figure here, the cracked version right here. So top portion normally you find zone like cracked zones, and below you will find a soft layer of lithomarge. So this section was taken in place called as Purnanand towards north of Goa. So this is another profile in North Goa, wherein we can see the laterite profile here, and the lithomarge layer is seen clearly. So this is another soil profile in south of Goa. This is a place called as Bali. So this figure is from another place in North Goa, in this place called as Bardes, which is close. So you can see here this clay, and you can see the color has also now changed. It has become from brown to dark brown color. So this profile granitic gneiss at the base from the gneiss, and this is almost orange to yellowish in color. So this type of lateritic soil is observed in South Goa, in place called as Kankona, where the color of the soil again changes to dark, you can say orange or brown. If we see now in Goa, these varieties of colors of this lateritic soils are observed, and all these color changes are due to presence of various minerals in it. So of these sections here where you can see how the lateritic soil changes the additions. So right from it's grayish, black, blackish, brown, and so on. So these are the soils. These are the typical properties of the laterites. This is from worldwide data. So specific gravity normally ranges from 2.5 to 3.6. These are CuC values. The range of 35 plus 20. And in the compaction test, the maximum dye density we can achieve up to 20 at moisture content of 15 to 30%. And C values range from 30, and friction angles are more than 30. So these are the general values which are observed all over the world. Then this mineral content is also, if you see, it varies. Saying et al. In 2018 presented that Sulawesi, Indonesia, has presented that kaolinite and illite is the major component. Where in Taiwan areas, if you find this, the component will be quartz and mica. In Nigeria, the major component is again, whereas in Kerala, it was observed to be gibbsite, quartz and mica. So this is, and all this is attributed to the presence of various levels of laterization because of natural agencies, that is temperature and water. So these are the mineral contents. If we see in some places like Indonesia, clay and silt is dominating, whereas in Kerala and Goa, you find that dominating factor will be somewhere major in Goa, it is silt and sand. The problem are cavity induced landslides also is a major problem, because as we know that in case of rainfall, this when water is absorbed by the soil, it becomes very soft in nature, and also sometimes settlement issues were observed. So these are some of the cavities which are observed in lateritic rocks. Okay, so these are the cavities which are seen here. Then the major problem in Goa is landslides. So these landslide which has occurred in 2018, where a vertical cut of about 20 meters was made for approach road here, and in the immediate rainy season, this slope collapsed. Yellowish to pinkish color layer, which is responsible for such collapse. These are few other landslides which has happened. This was in National Highway from Pundalik to Mapsa, where this is close to our Secretariat Assembly Complex, where this collapse had occurred and was blocked. This was on the hill in Vasco da Gama. This was another place in Madgaon, where the has occurred in the National Highway near Mardor, Goa. So these are the typical landslide has occurred in 2017 and 19 at various places. A place called as Chorla Ghat. This is near the Western Ghats, where it's occur every year. See during rainy season. In area also, one of my PhD student is working how these landslides can be controlled. So these are few other landslides issues. You can see how this building is in danger because of landslide. Then in few places we have studied the process. So G values lower side. Sometimes it is as high as 282, whereas lowest 0.29 and so on. So see the liquid limit is quite high here in Goa, 27 to 55 like that. Plastic limit is also quite high. And if you see the gravel and sand content is more in Goa as compared to other places. And C values are lower and 5 values are intermediate, not very high, more than 30, but close to 30, 32 like that. And even from starting from 15 degrees. So these are the soil properties where the failure is. So we have done this back analysis of Kandepar and Mardol site, where this slope was there. Here vertical cut was made of 20 meters with the properties. It shows that factor of safety is 0. And in Mardol site 0.602, which clearly if we make this vertical cut. Both were this unsupported vertical cuts. Then these are the properties at other side where we have some analysis. This place is called as Gaya, Ambaji and Kankon, where this height of slope was at one place it was 4.2 meters, other is 38 and 8.5. The factor of safety which were found were 0.84 and all the factors of safety where this landslide has occurred were less than 1. And various methods like say Gabion gravity wall, RCC cantilever wall, soil nailing were suggested. And after doing this analysis, we found that factor of safety improves to the extent of more than 1.5 in most of the places. So these are some of the. You can listen here. Soil nailing here, it shows that factor of safety improves to 1.4 here. Then at second side, Raya. So here after providing Gabion walls, it was found that strength reduction factor is 1.766. Okay, this is the third site wherein soil nailing was provided, and it was observed that if we do soil nailing for this slope, the factor of safety can improve to 2.339. And these are some of the we recommended for the site. Depends on the situation, means whether do the provide RCC walls or Gabions, considering the cost and also whether there is space available for a provider. So in most of the cases, there is limited availability of space, and traditional structures like cantilever walls or can be so Gabion wall was suggested in Raya site. A small height, it was only 4.2 meters house. So space was limited. So hence Gabion was found to be economical. In Ambaji, so it was proposed that at this site soil nailing would have been better, and in Kanpon site also soil nailing would have been a better solution for stabilization of the slopes. We also mapped this land. These are the places where we have studied different landslides, the places which are listed here. And if you click on these maps, it will give the details of the landslides which has occurred in the past. Then we tried to relate this behavior of these lateritic soils based on the mineral content. A study is going on in this area. We are trying to find out what could have been the reasons or presence of which minerals will result in landslides and other things. So this data is available from various sources. Observed that these laterite soils are dominated by clay minerals that have high plasticity like montmorillonite and illite. Laterite has unique property in presence of water, and say it will some extent are observed. All these landslides which are observed are mainly during the rainy season. Not a single landslide was observed in other season. Marge layer, which is exposed when we do the cutting, so that also can be one of the reasons of such behavior of you can say lateritic soils. Then critical assessment of macro and microstructural properties of the lateritic soil, so that we can control in future. So this is the data which is available, which shows that kaolinite content first increases and then decreases with increase in weathering. Means if the rainfall is very high, you will find less amount of kaolinite. If the rainfall is less, you will find kaolinite content can be more. So if this kaolinite content is predominant, then we find low plasticity, and cohesion will increase with increase in kaolinite content. So this was what observed when this kaolinite is found in predominant quantities. And if montmorillonite is present in predominant quantities, then permeability of the soil is less when montmorillonite is there, but the soil is highly plastic and also high activity. If goethite is observed in say more quantities, we find that specific gravity is also more, and this goethite mineral agent, and we may observe sometimes tensile cracking in this lateritic soil which contains goethite. Illite also found in some of the cases in Goa also. So this illite, these are non-expansive. Soil will be non-expansive if the presence of illite is in predominant. Minerals which are found in predominant quantities in lateritic soils. Finally, to conclude, these laterites and lateritic soils, they are developed by intensive and prolonged chemical weathering of the parent rock, the process which is pulverization, and this process due to heavy rain and high temperature probably seen in Goa. In India, these laterites are observed in peninsular India, Karnataka, Maharashtra, Goa, and they are very when they are wet, and they become stronger after drying and forms a good foundation material. In Goa, the laterite rock, of course, in this I have not presented much on the rock. The rock was found to be soft on medium in strength, and it is mostly porous and concretionary in structure. Classify this laterite in Goa as soft rock. The lateritic soils are found to vary in different colors also and mineral content. So where studies are going on finding the mineral content, and we are trying to correlate with the properties and reasons, trying to find out the reasons for landslides in Goa, and we know that rain is very, at least in our various maps, if we can include this lateritic and the sites which are prone to landslides. That useful data for the mineral content is known to be one of the influencing other factors like rainfall intervention. As you see, most of these slopes are cut vertically without providing any. So that also one reason is there. And in addition to that, heavy rainfall, and also we are trying to correlate this with the mineral content. So this will give us some insight on how these residual soils behave and how we can control the landslides which are happening in this. In Kerala and other states in Karnataka also we find these landslides which are occurring in lateritic soil, which has been a common problem in these places where lateritic available. Thank you very much for giving me an opportunity to present this theme talk. If any questions are there, I'll be happy to answer them.